The last thing you learned here at the end of May, very hard to focus, is about sine and cosine graphs. So the basic sine graph, y equals sine of x. Graph this a lot of times in radian mode. You start at 0, and of course it makes this little bubble thing. Sine and cosine both do. But this would be pi halfway through, like a circle halfway around is pi, and this is 2 pi. So a full revolution of a circle is 360, which is 2 pi. A full revolution of your graph is also 2 pi, or what we could convert to 360 degrees if we were talking degree form. Now that means this is pi over 2, and this would be 3 pi over 2. There's our basic key points of the sine graph. So we're looking at sine in this one, so we compare it. You can have transformations of the sine graph, and we need to talk about what they do. So I'm going to change colors here, and we have this 4. This 4 is going to stay, it's still going to start at 0, okay? But instead of going to a height of what was 1, it's now going to go to a height of 4. So instead of being at 1, we could say it goes up to 4, and we'd be right up here. That's going to change our amplitude. So I'm not going to put that dot just yet, but it'd go up to positive 4 and down to negative 4. This 2 in the equation is going to make us have twice as many cycles within 2 pi as did before. So the 2 would actually make it go twice as many times as it did last time. Okay, that changes your period. We call this the amplitude changer. And then finally, this number right here is going to shift the graph down by 3 units. It's a vertical shifter. So if we wanted to graph this entire equation, we would look at starting at 0, 0, going up to a height of 4, getting twice as many cycles in, and shifting down 3. In red here, I've graphed the graph y equals 4 sine of 2x. You can see the 4 because I'm up that tall and down that low. And the 2x means I've done twice as many cycles by the time I've hit 2 pi. Now I need to apply the shifter of minus 3. So the best way I find to do that is to go take my points here and move each one down 3, and I've done that, down to 3. So I'm just going to connect all these points. So I've moved that 0 down 3, move that lower part down 3, move this point down 3, move that point down 3, move that point down 3, and that point down 3. So this green graph would be my final answer for the shifter of 4 sine of 2x minus 3.